Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Hyperconjugation involves the delocalization of electrons from a sigma bond, typically CH or C to C, that is adjacent, alpha, to a pi system, into the pi asterisk or p orbital of that pi system. The sigma bond must be at the allylic position, directly attached to a sp2 carbon of the double bond, and must be properly aligned, parallel, with the pi system. Moving on to the next step. Identify the double bond in the molecule. The molecule is a cyclohex 2Na with a methyl group at C1. The double bond is between C2 and C3, using standard numbering. Moving on to the next step. Identify allylic carbons. The carbons directly bonded to C2 and C3, the sp2 carbons, are the allylic positions. These are C1, bearing CH3 and H, bond V, and C3's adjacent ring carbon, bearing H bonds labeled 2 and 3. And for the final step, bond I, CH at C1 of the ring on the upper left, allylic to the double bond. This could participate, but based on the answer, it is not selected. Bond 2, CH at the allylic carbon on the left side of the double bond. This is allylic and participates in hyperconjugation. Bond 3, another CH on the same allylic carbon, the H shown below. This is allylic and participates in hyperconjugation. Bond 4, C to C bond at the bottom of the double bond carbon. This is a ring C to C bond at the vinylic position, not allylic, so it does not effectively hyperconjugate. Bond V, CH at C1 bearing the methyl group, while C1 is allylic. Bond V is specifically the CH on C1, however, the answer does not include this. The bonds that participate in hyperconjugation are those CH sigma bonds at the allylic carbons adjacent to the C is equal to C. Bonds 2 and 3 are both CH bonds on the same allylic carbon directly adjacent to the double bond carbon, and they are correctly oriented to overlap with the pi system. These correspond to answer option B. Why other options fail? Bond I points away or is on a carbon not directly adjacent to the double bond in the labeled sense. Bond 4 is a C to C bond in the ring not at the allylic position. Bond V, while on an allylic carbon, is not included in the correct answer set B. Therefore, the correct answer is B. Therefore, the correct answer is option B.